Right, so our second section for this week is 3.4, okay, which is on a faster method of division than what we learned yesterday. It's called synthetic division. But unfortunately, you can't use synthetic division all the time. Okay, you can only use it for certain kinds of problems. So I'll show you when you can use it, and if you can, it is a lot faster. And we'll also talk about rational zeros. Okay? In other words, how can we find all the roots of a polynomial that are fractions? Okay? And that's the idea that's going to help us to take something that's a cubic and turn it into a quadratic. All right? So we'll talk about both of those today. All right, so if you have a function, okay, it can have both rational and irrational roots. Okay. Here's a function that if you were to solve it, the answer is rational. 0 equals x plus 3. Okay, what value would you plug in for x here in order to get 0? Yeah?
You would plug in -3.
Yeah, you plug in -3. And -3 can definitely be written as a fraction, -3/1. Okay? It's rational. Let's say I gave you this equation. 0 equals x squared minus 5. Okay, if you wanted to solve that equation, the first thing you'd have to do is add 5 to both sides. So you get 5 equals x squared. And how do you get rid of squaring something?
You do the square root.
Yep, you do the square root. So the answer to this problem would be the positive and negative square root of 5. Okay, square root of 5, that's irrational. Okay, any number that you take a square root of that is not a perfect square, the answer comes out irrational. Okay? There is no way you could ever write that as a fraction. Okay? There's no pattern, it doesn't repeat, just continually changes. All right, so we're gonna focus on how do you find the answers to a problem that can be written as fractions. Okay? Irrational answers, we're still going to have to use the calculator to help us with that. Okay, for some problems. All right, so in order to find all the roots to a polynomial, okay, to an equation that are fractions, okay, we're going to use what's called the rational root theorem. All right, so we're going to start out by saying, suppose we have some polynomial. Okay, it could be like, 8x cubed plus 7x squared minus 5x plus 6. Okay, we have some type of polynomial written in descending order. Highest exponent all the way down to my constant. Okay, all the coefficients, okay, all the things that I'm circling right now, are rational. Okay, so all the coefficients are rational, the numbers in front of the x and the constant. And the first number and the last number can't be 0. Okay, this theorem I'm about to show you wouldn't work if they were. Okay, so all your coefficients have to be rational numbers, so fractions. And the first coefficient and the constant can't equal 0. Right, so if we can find a rational root or a rational 0, okay, we could write it as a fraction. I just picked 2 letters. Okay, where p would be the number in the numerator, q would be the number in the denominator. And there's a method to how you find p and q. P could be any number that's a factor of the constant. So we're going to be generating a list of possibilities with this theorem. Okay, a lot of times, sometimes you only generate 2 or 4 different possibilities. Sometimes you generate up to 20 possibilities. It depends on how many factors there are of the constant. Okay, well, that's one of the things it depends on. So if I gave you a number like 12 for the constant, there's a lot of different factors. 1, 2, 3, 4, 6, and 12. So you got a lot of possibilities. if your constant was the number 5, well, there's not that many numbers that go into 5. 1 and 5. Okay, so how many possibilities you generate depends on how many factors there are of the constant. That's how you figure out the numerator. And the denominator is the factors of the leading coefficient. Okay, so when you do the rational root theorem, when you look at your polynomial, there's only 2 numbers that the whole theorem depends on. The first one and the last one. You don't need to look at anything in the middle. Okay, so P is the factors of your constant. Q is the factors of the leading coefficient. Okay, so we're going to be generating a lot of possibilities, depending on how many different factors there are. Just because it's in this list, it doesn't guarantee that it is a root. Okay? What we're going to be generating is just a list of options. Out of all that list of options that we generate, which ones are actually roots? Well, to check that out, we'd have to use either the graphing calculator, or we could do some synthetic division, which I'm going to show you next. Okay, so we're going to be generating a pretty big list for some problems, and not every number in the list is going to be a root. Okay, you'd have to investigate that list a little further to figure out which ones actually are roots. Okay, so we'll try an example. Okay, so in this one, I want to make a list of all possible rational zeros. I'm going to say possible. Okay, so in order to do this, first thing you have to do is figure out what are all the different values P could be. What are all the different values Q could be? All right, so P is any number that's a factor of the constant. Denver, what's my constant in this case?
-6.
Yep, -6. Whether it's a -6 or a +6, they actually have the same factors. But can you tell me all the numbers that divide into -6 without a remainder?
2, 3, 6, 1.
Yep, so 1, 2, 3, 6. 1. And does anybody see there's 4 other numbers that divide into -6 without a remainder? Yep.
-1, -2, -3, -6.
Yeah, all their negatives. Okay, so positive or negative, 1, 2, 3, 6. Okay, Q. So the denominator for my possible rational roots has to be a factor of the leading coefficient. Okay, in this case, my leading coefficient is 10. John, what are all my factors of 10?
1, 2, 5,
1, 2, 5, and 10, and
-1, -2, -5, and -10.
yep. Okay, so if this problem has a rational root, okay, if it has a fraction that you can plug in for x, do out the arithmetic and get 0, it has to be of the form P over Q. So now we need to write out all the different combinations you can have with P in the top and Q in the bottom. Okay, and if you do it systematically, it's not too hard. I like to start with 1, positive or negative 1, and put that over every denominator I could have. Okay, so I could have positive or negative 1 in the top, and then I could have divided by positive or negative 1. I could have positive or negative 1 over 2. I could have positive or negative 1 over 5. And I could have positive or negative 1 over 10. Okay, that's all the different P over Qs I could have with 1 positive or negative in the numerator. Okay, so the next one I'm going to do is 2. Okay, somebody tell me one of the roots I could have with positive or negative 2 in the numerator? Yep, Denver.
Positive or negative 2.
Yep, positive or negative 2. You want to keep going?
Positive, negative 1.
Yep, so the next one he did was positive or negative 2 over 2, which is really just positive or negative 1. So we already have that one. What would be the next one?
Positive, negative 2/5.
Yep, positive or negative 2/5. And what would be the last one?
Positive, negative 1/5.
Yeah, positive or negative 2 over 10, which is 1/5, and we already have that one. Okay, so those are all the denominators with numerators that you could have with 2. So now let's do 3. So positive or negative 3 over 1. Austin, can you give me my next one? Not sure. Oh, Connor, can you help him out? So we're just trying to make a list of all the different fractions that are of the form P over Q. Jack?
Positive, negative 5.
Can you tell me how you got that? So you had 3 in the top.
You do 2 in the top over 10.
That would be 1/5. So we already did all the ones with 1. We did all the ones with 2. Now we're doing the ones with 3. Kenna?
Plus or minus 3 over 10.
Yep. Plus or minus 3 over 2. And can you do the last one for me?
Plus or minus 2 over...
Yep, actually there's a couple more. Plus or minus 3 over 5. And
Plus or minus 0.
plus or minus 3 over 10. So those are all possibilities with 3 in the numerator. Now let's do the ones with 6.
Takes up a lot more space than the last one.
This one?
Yeah.
Yeah, there's a lot of possibilities for this one. Most problems don't have this many. But this is a good one to do because you can really, if you can do this one, you could do any of them. How about with 6 as the numerator? What are my possibilities there? Yep, positive or negative 6. Okay, the next one would be positive or negative 6 over 2. Do I need to write that one? No. I already have it. Positive or negative 6 over 5. Do I have that? No. And the last one, positive or negative 6 over 10. Do I have that? 6 over 10 reduces to 3/5. Okay, so I already have that. Okay, so if there is a number you can plug in for x, that's a fraction, that makes it come out to 0, I guarantee you it's in that list somewhere. Okay, so this generates a list of possibilities. I'm not saying every single one of these you plug in for x and get 0. I'm saying if there's a number, it's in that list. Okay, so on the test, the kind of question you're going to see on this, it won't have this many possibilities. But it's going to be in 3 parts. Okay, the first part is to do what we just did. List all the possibilities. Okay, the second part is going to be graph it and eliminate the ones that don't make any sense at all. Okay, so we're going to start to narrow down the list a little bit. Okay, can somebody tell me what was the original problem? I know it was 10x
To
to the 5th. Yep.
minus 3x squared
Minus 3x squared
plus x minus 6
plus x in the last term
minus 6.
minus 6. Thank you. Okay, so I'm going to hit graph. And if there's a rational root, I don't need to look beyond 6 and negative 6. Every number that you see up here is between positive and negative 6. Just looking real quick. Okay, so I'm looking at my standard window. Okay, let's go through each root. Does positive 1 look like it could be a root? Could be. So I'm just going to call these like candidates. They could be. Positive 1. How about negative 1? No, doesn't cross anywhere near negative 1. Positive or negative a half?
Yeah.
It doesn't look like it's crossing near 1/2 to me. I mean, I could zoom in a little more, but I don't think it is. How about positive or negative 1/5? No. 1/10, positive or negative? No. Positive or negative 2? No, it's not near those. It's not near, well, positive or negative 2/5. That's 0.4. Not really. Positive or negative 3? No. Positive or negative 1.5? That's 3/2. Not really. Doesn't look like it's at 1.5 to me. Positive or negative 3/5? That's 0.6. If you said that could be a candidate, I would be okay with that. 0.6. That's kind of close to where that line is. Okay, so I would say 3/5. You could argue that that's a candidate. Negative 3/5? No. 3/10? That's 0.3. Not really. Plus 6 minus 6? No. How about 6/5? Yeah, 6/5. That's just like 1.2, roughly. So I'd say that it could be a candidate. So out of all the possibilities, those are actually the only ones that it could be, and I'm leaning towards it being positive 1. Okay, but I'm not sure. I'd have to check it and see.
No, why would it 1/2 be possible?
Just to me, if I look at the graph and make it bigger, 1/2 is right here. And I don't know, it just doesn't look close enough to 1/2 to me. Really, it really looks very close to 1. What's that? Yep. That's how you do it. All right, so any questions on that? All right. So now the last part, I want to take that same problem we just had. I want to show that it does have one real root. In other words, it only crosses the axis one time. But I want you to prove to me that where it crosses is an irrational number. Okay, and we're going to use the graphing calculator to help us. Okay. So on the calculator, how do I calculate where it crosses exactly?
Isn't it like intersect?
Not for a root. You can use intersect for other things, though, yeah, but not for this. Remember, Priya? Yeah, I'm going to do second calc 0. Second calc, second option down. Pick a point to the left, to the right, and do your guess. And this crosses at 0.9505. Okay? So it's close to 1, but it's not 1. So how can I prove that that number is irrational based on what I just did? Why does 0.9505, it has to be irrational? Yep?
Because none of those numbers equal that.
Yeah, it's not in this list. This is the list of all the rational roots, every possibility that could happen. This number is not in that list. So if this is all the rationals, and that number is not in the list, it must be irrational. All right? That's how you prove it's irrational. Okay, so since, and it's not even exactly 0.9505. I rounded that. Okay, so since 0.905 is not in the list of rational roots, it must be irrational. Okay, so any questions on that? So when we do some of these problems later today, there's not going to be as many possibilities. Okay, that's the largest one that we do every example in class. Okay, and there's nothing that many on the test either. Okay, but that's how you do the rational root theorem. Okay, any questions on the theorem before we move on to synthetic division? Okay, if you're a little shaky or you're not sure, we are going to do another example with it, but I want to show you synthetic division first so we can do the rational root theorem with synthetic division. All right, so basically, synthetic division gives you a quick way to do long division, but it only works when you divide by x minus c. Doesn't work if you want to divide by x squared, x cubed, anything else. Only works when you divide by x minus c. And it would also work for x plus c. Okay, we just have to be careful with our sign. Okay, so we'll go through one of those.
What is C?
C is a constant. It's like a rational number. So it could be like, take this and divide by x minus 7. Okay, if I wanted to divide this by x minus 7, I could do synthetic division. Okay, and I'm going to show you where C goes in a second.
Okay.
It's part of synthetic division. All right, so what I'm going to do here is I want to show that 3/2 is a root of this. Okay, it's a number you could plug in for x and get 0. Showing that 3/2 is a root, showing that it's an x-intercept, same thing, is the same as showing what is a factor. So since 3/2 is a 0, what does that mean is a factor? John?
X minus 2 over 3.
X minus
2 over 3, or is it 3 over 2?
3 over 2. Yeah. Okay, so if you're telling me that 3/2 is a root or a 0, that's the same as saying x minus 3/2 is a factor. So what I'm really going to do is I'm not going to show that 3/2 is a 0. What I'm really going to do is I'm going to show x minus 3/2 is a factor by doing long division. Well, actually synthetic division. Okay, but that's the same thing. Okay, so any questions on the approach I'm going to take? If I show that x minus 3/2 is a factor, in other words, when I divide it, I get a remainder of 0, that proves 3/2 is a root. Same thing. All right, so now I'm going to show you how to do synthetic division. Okay, first thing you have to do is put down the number that comes after the minus sign, okay, in the bracket that I just made like that. Okay, so let's do that. Make a bracket and put down the number that comes after the minus sign. Okay, so in my problem, what am I trying to show is a root? Or what's the number that comes after the minus sign?
3 over 2.
Yep, 3 over 2. So that's what I'm going to divide through synthetically by. Okay, so what I'm about to do is this. I'm just going to do it a lot faster than the way we did yesterday. And if I'm hoping that this is a factor, what am I hoping that I get a remainder of when I do this? 0. Perfect. Okay, so write down the number that you think is a root. Okay, that's your root. And now fill in zeros for any powers we're missing. Okay, cubed, squared, linear, constant. We're not missing anything. What's nice about synthetic division? Well, 2 things. 1, you don't write any letters in the whole process. Okay, and 2, it's not going to take up any more space than what's in that box. So it's not like long division where you get keeps kind of going down and to the right. Okay, any questions on step 1 for synthetic division? Yeah.
So when you're asking a question like this, will it give you the constant?
Yeah, I'll give you a constant and I'll say prove to me whether or not it's a root. Yep. All right. Next step. Bring down the first coefficient. Okay, so what I'm going to do is just put a line in here to separate. I'm going to bring down the 2. Next step. Okay, you're going to multiply the 3 halves times the coefficient we just brought down. And we're going to write the answer in the second column. Okay, so we're going to do 3 halves times 2 and put the answer under the -5. Okay, what's 3 halves times 2? Yep. 3. So I just multiplied my divisor by the coefficient I brought down, and I put the result in the second column. Now I'm going to add the number that I just wrote and the second coefficient. Okay, I'm going to add these numbers up. And I think this is where people get confused, because with long division, you end up subtracting. Synthetic division, you add. So you've got to keep that straight. Alex, what's -5 plus 3? -2. Okay, and now we repeat that until we're done. Okay, I'll explain to you how you look at what you've got here and determine what the answer is, but let's do it again. What's 3 halves times -2? Check.
-3.
Yep, -3. Put the answer in that column. Add the 2 numbers in that column. -2. All right, same thing again here. What's -2 times 3 halves? -3 again. And what's 3 minus 3? Or 3 plus -3? 0. Does anybody have a guess what number, what this 0 represents? That's my remainder. So what do you think these other 3 numbers are? Coefficients of my, which are the what when we do division? My quotient. Okay, these numbers are the coefficients of my quotient. Okay, so the quotient, the way you figure it out is you start all the way at the right, okay, except for the remainder, that's by itself. That's the constant. That's the number in front of x. That's the number in front of x squared. Okay, that's how I do it. Just count what's the highest power you need. So 2x squared minus 2x minus 2. Remainder, 0. Okay, so since I just did this problem right here. Since x minus 3 halves divided in without remainder, that means 3 halves is a root, or 3 halves is a factor, or 3 halves is an x-intercept, however you want to say it. Okay, and that takes the place of all the long division we did yesterday. Okay, the trick is, how would you come up with this 3 halves on your own? Rational root theorem. Okay. Factors of p, factors of q, you can probably see 3 divided by 2. That's where that comes from. Okay, so in one of the problems coming up, you're going to have to figure out this number on your own and then do this process. Okay, but this time I gave it to you. Yeah, question?
Oh, no, you answered it.
Hey, any questions on that one? Okay, just remember with synthetic division, it's always the number after the minus sign. So if you've got a plus sign, well, we'll do one like that and think about what you might have to do. All right, so I want to use synthetic division to do this. Okay, it's not set up exactly the way it should be, but we can still use synthetic division. Okay, so anyone think they can tell me what is going to go on this bracket? What number I'm going to put in it? Bria? Right. Think of it like this, x minus 3. Okay, that's what you're dividing by. So different ways I could word this question, and you do the exact same thing we're about to do on the test. I could word it like this. Okay? I could say, prove to me -3 is a root of that. Okay? You do exactly what we're doing right now. In fact, that's the way I worded it in the last problem. Prove to me that -3 is a 0 of what I just circled. Prove to me that if you graph this, it would cross the x-axis at -3. All those directions I just said are exactly the same problem. All right, so now we've got our -3. Put down our coefficients. Can someone tell me what my coefficients are going to be? 3, 7, 0, 1, -11. Why did I put a 0 in there?
X squared.
Right, I'm missing the x squared term. Yep.
How come you made that -3?
So when you do synthetic division, okay, you always have to put in the number after the minus sign in the denominator. This time the denominator had a plus sign. All right, so instead of thinking of it as x plus 3, I'm going to write it as x minus -3. That's the number after the minus sign. Okay. So you just got to remember, it's always the number after the minus sign. If you don't have a minus sign, make a minus sign. Okay, just like I did right here. Okay, other questions before I start this process? All right, so what's the first thing I do? Sam? Bring down the 3. Next step. -3 times 3, which gives me -9, and now add. What's 7 plus -9? -2. Multiply. -3 times -2? +6. Add. What's 0 plus 6? 6 times -3? And 1 plus -18. All right. -3 times -17.
54.
Doesn't end in a 4.
51.
51. And what's, well, 51 minus 11, or -11 plus 51, same thing.
40.
40. So, can somebody interpret my result here and explain what this means? I what?
It is not a 0.
What number is not a 0?
X plus 3 is not a 0.
Careful. You can say x plus 3 is not a something, but you can't say x plus 3 is not a 0.
Not a factor.
Right. We could say x plus 3 is not a factor. What else could you say? Yep, Jack?
-3 is not 0.
-3 is not a 0. You could also say a small change. -3 is not a root. This graph does not cross the x-axis at -3. Any of those 4 statements are all equivalent. All right. Questions on that one? Okay, so once you get used to the synthetic division, it really is pretty fast, as long as the numbers you're multiplying and adding aren't too difficult to do in your head. Okay, so example 5. Now we're going to show that 3 is not a 0. Show me 3 is not a root. Prove to me the graph doesn't cross the x-axis at 3.
Couldn't you just graph it?
It depends if they say to do it algebraically or graphically. Yeah, if they say do it graphically, you could. If they say do it algebraically, you can't.
Don't
So,
you get the same answer?
what's that?
Don't you like get the same answer though?
Yeah, if you do it correctly, you'll get the same result. Just depends on how they ask you to do it.
Yeah.
It's like if you had a quadratic equation and they say solve it by factoring, don't use quadratic formula. Get the same result. Just- All right, so what number would I put on the outside here? What's the number that I'm testing to see if it's a root? 3. Okay? So basically what I'm doing is I'm taking this and I'm going to divide it by x minus 3 using synthetic division. What am I hoping that my remainder isn't? Because
Zero.
I'm trying to show that this is not a root. So I'm hoping my remainder is not what?
Zero.
Yeah, I'm hoping I don't get 0 for the remainder. Okay, what are my coefficients?
Those ones don't-
2.
Yep, 2. All right, so let's go through it pretty quick. Bring down the 2. 3 times 2 is 6. 5 and 6 is 11. 3 and 11 is 33. 31. 93. 90. You can check, make sure I didn't make a mistake, but I don't think I did. Okay, so what's my remainder? 90. So I'm just going to write, since my remainder is 90, what did they ask me? I want to word it the way they did. 3 is not a 0. What is not a factor? X minus 3 is not a factor. What's not an x-intercept? Yep, 3. Okay. I'm not going to write all those. I just want you to understand them because you need to understand all those different terms for the test. Okay, and that's it. So it's a lot faster than doing long division. Okay, you could also use the remainder theorem to do this. We learned that yesterday. You could plug in 3 for x. But I would argue I can do the synthetic division faster than you could do the remainder theorem. Because if I have to plug 3 in, I need to cube it and then double it. Then I need to square it, multiply it by 5, and add it to my result. Minus 6, minus 3. I think I can still do the synthetic faster. Okay, but if on the test they asked you to find the remainder, and you don't want to do synthetic division, and they don't tell you you have to, you don't have to use synthetic division. Although I think it is the fastest in most cases. All right, so the strategies that we can use to find rational zeros pretty much go in this order. Start with the rational root theorem to make a list of possibilities. Use the graphing calculator to narrow down that list of candidates. And finally, once you find a candidate, divide through by it synthetically. Okay? And what that'll do, especially in this case, is if you can find a rational root and you divide through, it'll turn the cubic into 1 degree smaller. And what's the degree below a cubic? A quadratic. And if you can turn something into a quadratic, then you can use anything you learned in Algebra 2 to solve it. Complete the square, factor, or quadratic formula. All right, so they want us to find all rational zeros in this problem. Rational zeros. And then in the last problem, they're having us do real zeros. Okay, but notice they're all cubics. So that means you're going to be able to find a root and use synthetic division and turn all these cubics into quadratics. If I don't give you a rational root, you'd be stuck. You can't do the problem. All right, so let's start by making a list of all the possible rational roots, and there's not that many in this problem. Okay, P is going to be all the factors of what number? The constant. Okay, P is going to be all the factors of -2. What are all the numbers that divide into -2?
1.
Plus or minus 1? That's it. Okay. Q is all the factors of what number? 1. No, it's not there. That's the number. What are all the numbers that divide into 1? That's it. So there's not going to be that many options here for rational roots. Okay. What are all the different fractions I could have for rational roots? Plus or minus 1, plus or minus 2. You might say, well, those aren't fractions. Yeah, they are. You could put denominators of 1. Okay, so now that's my list. Now I'm going to use the graphing calculator to get a list of possible candidates. So I'm going to narrow that list down. Okay, so we've got x cubed minus 3x minus 2. Okay, does it look like plus 1 is a candidate?
No.
No. How about minus 1? Yep. Oh, might be easier if I just put it here. All right, so minus 1. How about plus 2?
Yeah.
Okay. You don't have to put the plus, just 2. How about minus 2? No. So these are the only candidates. Okay. I'm going to try dividing through synthetically by 2. I actually think they both work, so it doesn't matter which one we use in this case. You could check, just go to trace, type 2, and you can see, yep, it is a root. So we're going to divide through by the root. And remember, if we already know something is a factor, okay, which I do, I know x minus 2 is a factor of this, okay, because I graphed it and it crosses the x-axis at 2, which means x minus 2 is a factor. Well, when I divide through by x minus 2, my quotient is also a factor. Okay, so I'll get my quotient, and then I'll find the roots of that. All right, so I need 1, 0, negative 3, negative 2. Okay, bring down the 1. What's 2 times 1? 0 plus 2? 2 times 2? Negative 3 plus 4? 1. 2 times 1? And negative 2 plus 2? 0. So we already knew we were going to get a remainder of 0, but this is what I was after. That's my quotient, and that is also a factor. X squared plus 2x plus 1. So if you wanted to factor the original problem, that's how it factors right there. And I think this part we can factor even more. Okay, remember, if it's a cubic, you can always break it down into 3 sets of parentheses. So let's factor x squared plus 2x plus 1. Okay. How does that factor?
X and X.
X and x.
Plus 1 plus 1.
Plus 1 plus 1. So we have 3 roots in this problem. We know 2 is a root, because we got remainder 0. And what are the roots I get from this one? Negative 1. And what's special about negative 1?
Double.
Yeah, it's a repeated root. So that's where it looks like it comes up. It touches the negative 1 and it bounces away from it. Okay, so there are 3 answers. 1 is a repeat. And that's pretty much how every kind of problem like this goes. Rational root theorem, graphing calculator, synthetic division, and then factor at the end, or worst case, quadratic formula. Okay. Any questions on that one? Yeah?
Instead of doing the last part, like where you do the last bit of factoring there, wasn't the negative 1 the same as the root that we found above? So couldn't you have just tested that on the calculator as well?
Yep, you could have put a negative 1 right here and done the same thing. You would have still gotten a quadratic, but it would have factored differently. Yep, but it's still, you would have done the exact same thing. Sometimes you don't have a choice, like you only can find one. This time we had a choice. Doesn't matter which one you use. All right, let's try this one. Is that the same? No, it's a little different. Okay, 6x cubed minus 5x squared plus 3x minus 1. Factors of p?
1 and negative 1.
Yeah, so that's going to be nice. There's not that many choices. Q, there's some more choices, but not as bad as the first problem. We already did the factors of 6. 1, 2, 3, 6. So what are all the different fractions I could have with p in the top and a q in the bottom?
1,
1. What else?
-1,
Yep, plus or minus 1.
1 over 2,
What else?
1 over 3,
Before you get to that one.
plus or minus,
Yep, plus or minus a half.
plus or minus 1 over 3, plus or minus 1 over 6.
So if there's a rational root, it's one of these 8 numbers. Let's graph it and see if we can get a list of candidates. Okay, narrowing down a little bit. Okay, so we've got 6x cubed minus 5x squared plus 3x minus 1. Okay, these are all going to be pretty close. 0.5, 0.3, okay, 1. So it's going to be hard to tell. Let's zoom in a little bit. Zoom 2 in. Does it look like plus or minus 1 is a candidate? No. How about plus a half?
Yeah.
What's the scale on that?
Yeah, that's a good question. I think it's going by ones. Yeah, it's going by ones.
Oh.
So each check mark is 1 unit. How about plus a third?
No.
Yeah, I wouldn't mark it wrong. I mean, a third is probably right about here. So it's,
Yeah.
it,
I said that work.
I wouldn't mark it wrong if you said it could be, but I'm leaning towards a half.
Yeah.
1/6, I would say.
Definitely go.
No, 1/6 is like right there. All right, so let's try 0.5 and see what we get. Okay, 0.5 is a 0. And now we'll divide through synthetically by it, and it'll turn the cubic into a quadratic. Okay, what are my coefficients?
6,
Yep,
5, 3, -5, 3, and -1.
6, -5, 3, -1. I already know the remainder. What's the remainder going to be?
0.
It's going to be 0, but I'm interested in the quotient, and I want to see what answers I can get from that. So 6, half of 6 is
3.
-5 plus 3.
-2.
Half of -2.
1.
-1,
3 plus -1.
2,
And half of 2, 1. So there's my quotient. So we can see if we can factor that. So you got 1 and 2. I don't think that's going to work. Okay, so we can try quadratic formula. So A is 6, B is -2, C is 2. But I think you'll probably see what's going to happen here. So we've got -b plus or minus the square root of b squared minus 4 times a times c all over 2a. All you need to do is look at this. That tells you what's going to happen.
Would that be
Oh,
plus
it's gonna be
and
a
the 2
negative.
minuses would cancel out?
So yeah, this is going to be a negative square root. That's 4 minus.
Oh, I just never mind.
So what does that mean if that's a negative square root?
It has to be imaginary.
Yeah, it has to be imaginary, and this problem said to find rationals. Okay. So what are the only rational roots in this problem? 1/2. That's it. Okay, we're not doing the imaginaries today, but tomorrow when we do them, you do everything we just did. Just finish this off. Okay, but I'm not going to finish it today. Okay, and last problem. Okay, this time they want us to find all real answers. Okay, so not the imaginaries, but if you have an answer that can't be written as a fraction, like if it's got a square root in it, we'll find it. Okay, factors of p. not that many, just plus or minus 1 and 2. Factors of q, plus or minus 1 and 3. Another thing that the rational root theorem helps you with is it gives you an idea of where to look in your window. Okay? Once I write my rational roots, I know I'm not going to have to look way out at like 20. Okay? Because I'm not going to have anything like that. Okay, so what are my rational roots here? Ian, can you give me one?
A rational root is plus or minus 1.
Or at least, yeah, possibility. Yep, plus or minus 1. What else? Yep.
Plus or minus 1 over 3.
Plus or minus 1 over 3. And 2 more. Plus or minus 2. Plus or minus 2 over 3. Okay, what's the next thing I do after I have my list? Yep, find the ones that are reasonable. So we've got 3x cubed minus 8x squared. Can somebody tell me what's the constant? Plus or minus?
Plus
2. Thank you. Okay, so I'm kind of zoomed in, but it doesn't matter. I'm looking between -2 and 2 anyway. All right, so we do have three roots. What looks reasonable here?
Negative 1/3.
Yeah, I'd say could be -1/3. What else?
Definitely not 2 and definitely not 1.
How about 2/3?
Yeah.
Could be. I'd say those are the only ones. Before I do synthetic division, I like to try the one that I think it is, and that way, when I do synthetic division, I don't waste time. Okay? I only want the one that really gives me 0. It's 2/3. It's probably not -1/3. Nope. -1/3 is not. It is a candidate. It does look pretty close to it, but it actually doesn't work. Okay, so we're going to divide through by 2/3. Okay, I have 3, -8, 1, 2. What's 2/3 times 3? 2. And then -8 plus 2? -6. Okay, 2/3 times -6. Think of it this way. What's 2 times -6?
-4.
And divide that by 3.
-4.
There you go. 1 plus -4. And now 2 times -3.
-2.
Yeah, -6 divided by 3, -2. That's my remainder. And now I know this part will not factor. So my only way to solve it is with what?
Quadratic.
Quadratic formula. A, B, C. Right, so -b plus or minus, what comes next? B squared minus 4ac all over 2a. Now this time what's going to happen, we have minus a minus. Okay, so that turns into a plus. So we will not get imaginary answers. Just simplify that and you're done. What's 4 times 3? 12 times 3? And then plus, what's 36 plus 36? 72. All right. Can anybody think of a perfect square that divides into 72? So numbers like either 1, 4, 9, 16, 25, 36, things like that.
16.
I don't think 16 divides into 72, does it? Let's see. No, not quite. 9 does, but there's a bigger one if you do it. You don't have to do it twice. But you could do 9. You'd have to do it again, though.
12.
12 is not a perfect square. So 1, 4, 9, 16, 25, 36.
Yeah.
36. If you write it as 36 times 2, which is 72, what's the square root of 36? 6 plus or minus 6 root 2 over 6. And what can I cancel from everywhere? 1, 1, 1. Okay. So your final answer is 1 plus or minus square root of 2. That you couldn't get on the calculator. You could get a decimal, but the calculator can't give you this. Okay?
Should be.
So that's why you have to know how to do the quadratic formula. Okay? If it's a multiple choice question and you get this as an answer, just make sure you know how to reduce it, because I would not have this as a choice on the test. I would have this. Okay, so that's 2 of my roots, and what was my other root? 2/3. Okay, so three roots. All right, so it is a little time consuming. That's why on the test, I think there's only like 1 of those, 1 or 2. So the whole test is only going to be 14 problems, and the first 7 and the last 7 are the same, except I change a number. Okay, so the same exact problems, just I change a number. Okay. Question? No? All right, so homework tonight, just really a bunch of individual problems. It's 11 questions. So it's 1, 2, 5, 6, 9, 10, 13, 14, 17, 18, 27. Okay, so we'll look at that tomorrow, and we'll finish up everything for the week tomorrow, and I'll also be here for extra help on Thursday. Definitely come see me if things are a little confusing. Okay?